Thank you for joining, everyone. I'm Cassidy Phillips, VP of Networking Solutions at Imagine Communications, and I'm joined by Tony Pearson and Sean Colvin from NC State. So, Tony, why don't you tell us a little bit about what you do at NC State and what the Delta program is?
Well, thank you, Cassidy. Of course, our program basically is the production element of our distance learning classroom support. And so the role of Delta is to foster the integration of support of learning technologies and NC State's academic programs, both on campus and at a distance. And Sean and I, we're charged with maintaining all the what we call media enhanced classrooms that provide distance education to students on campus as well, but as afar also. So that's kind of what our mission is, basically providing distance education to off-campus students with supplemental materials to on-campus students.
And Sean, what is your day-to-day?
Hi, Cassidy. Yeah, so I am a Classroom Services Manager with the Video Communication Services. I manage a group of classroom support technicians that provide instructional technology support for our media-enhanced learning spaces in support of distance education for the university.
Excellent. So, Tony, give me a little bit of the history of the Delta program at NC State.
Well, Cassidy, Delta started back in 2000, but the unit that we operate also was prior to Delta. So we were doing distance education prior to Delta as well. So we have over a 30-year history of providing services to the campus and stuff. Delta came on in 2000 to do a consolidation of distance education efforts throughout the campus, which allowed us to grow into a solid support vehicle for the campus. We continue to do what we do on our side, providing classroom support for these media enhanced classrooms. At the time Delta came on board, we were still growing. Our classrooms at that time, we had about 5 classrooms at the time that were completely outfitted for media and stuff. So inside these classrooms, you end up having about 7 to 8 media sources and additional sources as well come into play with all the computer applications as well. But every classroom that we have will have anywhere from 5 to 6 cameras. And that allowed us to not only do synchronous learning, but asynchronous learning as well. So we also run an enterprise classroom capture solution as well, where everything we record is captured and it's provided to the students immediately. So we do a real-time production process. Everything that Sean's team produces is pretty much online within seconds after they hit the stop button.
Right, right. So it's almost like a combination, for the uninitiated, it's like a combination of learning, education in a school, but also this live production broadcast system.
Correct. It's real-time production. I mean, everything is recorded live. So when a faculty member comes into the classrooms, the technicians are generally, at our central location. They reach out, they talk into the classroom, and they're able to go ahead and get the instructor going. A lot of our faculty are pretty savvy. They come in and they can pretty much start things, immediately, and the technicians are just monitoring things. And so a lot of times, we have, seasoned faculty that come back and forth, and they kind of like say, hey, I got this, I can do that. And the technicians are kind of there just as a support model, basically to be there to get them out of trouble and stuff. The way our system is set up, there's two-way interaction between the classroom and our support center and stuff. And so anytime anything happens in the classroom that's out of kilter, the faculty member just hit a help button, and you get the technicians give real-time interaction to them by popping up on the back screen in the classroom and say, hi, Dr. So-and-so, how can I help you? And stuff. And they go, oh, well, the projector's on. So they can turn the projector on. At our center, at our support center, we can see every single source that comes into that center, which was kind of the emphasis for the project that we're going to discuss here and stuff, is that real-time is very important to us to be able to see all the signals and sources coming from these classrooms that are in various locations on the campus.
Yep. And those various locations are one of the interesting problems you guys had to tackle. So we actually have a map, a bird's eye map of the NC State campus, and we can see the facilities distributed across the campus, and we have just a very high level line going to each of these. So, for example, on the next slide, you can see we have the most distant facility that comes off the page on that first map. So you guys have quite a bit of distance between some of these classrooms and your central control. So talk a little bit about what that used to be like and what problem you guys were trying to solve with the new system, in addition to just general capacity.
So just to clarify, I mean, when we look at these maps, I want to make sure that, we don't misinterpret the maps as well. The maps basically show that we have 6.5 miles and 5.2 miles to our longest facilities. But, as far as the crow fly, it's only about a mile. Okay, so we're talking about for the fiber to go around campus to get from point A to point B and stuff. And so it takes from the point that it leaves the main campus to get to MRC, which is our farthest location, is 6.5 miles. But that's just for the fiber runs that have to run around the hops on the campus to get to the final destination. If we had to walk over there, we're probably talking, like I said, a mile to a mile and a half, depending on which way you're walking, to get there as a straight shot. But our complicated matter with that was that, we've ran a fiber infrastructure since the very beginning. When we started this thing, fiber was used to transmit our classrooms to microwave towers, to satellite feeds, and things like that. So basically, we repurposed all that fiber to start the centralized, operations of our center, and started to use that as our monitoring solution. And it was kind of complicated at times. The first system that we put in about 10 years ago was sort of a hybrid solution where we actually use multi-viewers to feed multi-viewers. And at the time, we had 4 fibers that we used to run from each classroom. So we couldn't feed every single signal or video feed down those fibers to the center. So we had to bring in a multi-viewer application at that time to see how we can bundle those sources together and transmit them as one block over to the centralized.
Right.
And that gave us more of a quad split look. And so it handicapped a lot of what we could do. We couldn't pull all the signals out, and we didn't have all the signals in the multi-viewer. So a lot of things had to be rerouted and stuff. So it was kind of a handicap for the technicians to run from. And Sean can speak a little bit more about that, because at that time, Sean was actually one of our technicians, and he can talk about some of the deficiencies in the old system now versus the new system.
Yeah, I think definitely centralizing the operation definitely maximized efficiency for the team. When I first came on board, as Tony stated, the setup was entirely different. So there were physical spaces, physical control rooms connected to the classrooms. In some instances, there still are, but we converted down to basically closets that maintain the equipment. Prior to that, we operated from a physical control room there on site at the classroom space. And so we had all of our video and audio controls, camera controls there, where we maintained a certain level of, interaction with faculty. It was a lot of hand holding, where they could reach out to us and we'd be available to walk into the door and kind of help them along with technology within the classroom spaces. But then when we centralized, we wanted to maintain that same type of standard, right? We wanted to be able to engage faculty members in a similar fashion that they were accustomed to, but just from a centralized location.
Right, and part of this, obviously, you guys have a low tolerance for latency, right? I mean, it can't take a bunch of time for the signal to get from one place to the next, and you guys are meant to be very responsive to anything that arises. So that's part of why it was good to have that room right next to the classroom, because you guys needed to be able to respond quickly. But now with the centralized operation, you can still do that, but you have to make sure you don't have a bunch of delay between those signals across your facility, right?
Exactly. Latency is certainly key. And again, we establish a certain standard in the products that we produce. And so, responsiveness is extremely important. It definitely is shown in the final product if there is an extended amount of latency involved in the switching and delivery of support.
Yep. So you guys started looking at ways to update the system. Talk a little bit about the project timeline.
Well, that was kind of the I would say the big picture thing with us is, we started back in 2015, and we started researching a lot of next gen technologies, and we were basically just trying to determine at that time what was going to be the next model for our applications that we were running. We also wanted to make sure that we factored in the future. So we didn't want to buy into an old legacy, technology that would lock us in down the road here. We wanted to find something that will allow the system to continue to grow. We wanted to be able to look at more of an open standard solution, looking at COTS equipment and everything like that, to be sure that it just didn't lock us into a proprietary system and stuff. So that was kind of key in the very beginning and stuff. And like I said, we had a laundry list of criteria that we wanted to maintain and stuff. And we were kind of stickler on that in the beginning and stuff. So, when we started this whole process back in 2015, we didn't know where it was going to go. We started evaluating every single thing out there. We were looking at, every type of IP streaming device that was out there. We brought things in. We test ran a lot of things and stuff. So Sean was charged with bringing in all these different encoders and devices, and him and the engineering team were basically working to see which was going to work, which wasn't going to work, what was going to be, disallowed on our network. We engaged all of our networking engineers on campus. We had them involved from the very beginning. We started talking about what can we do with the network, and then we started dealing with the fact that, we're using a lot of, high quality video, uncompressed video and stuff. And so when we started looking at some of these encoding devices, things would be, they would be compressed. They were severely delayed. We looked at buffering issues and things like that as we started testing things, and even going into the first generation of what our operation center is, that was a criteria there, as Sean had talked about. Latency was a big issue because we're operating classrooms remotely and stuff, and we're having to engage cameras and put cameras back in place and stuff. And, we rely heavily on tracking cameras in our solution as well. And a lot of times the tracking cameras aren't as reliable as we like them to be. They just go off into wonky land every now and then. And so the technicians have to engage and pull those cameras back. And if latency was an issue, you're trying to catch up with a moving faculty member. It's like, hey, okay, I can't catch up with him because, hey, we're 2 to 3 seconds behind here, and issues like that. So we tested several solutions even in the beginning, and we came down to the fact that it couldn't be any more than, a few nanoseconds of a delay that we could tolerate and be able to get away with it at that time and stuff. So that was kind of some of the emphasis there, as we rolled into, the next year, as we started to engage the different manufacturers, the different vendors, we started to talk about things. We looked at the capacity of our current, well, it's not current now, but what we used to have, our SDI multi-viewer system that was in play. We looked at the roadmap of that company. We looked at the roadmap of those systems. We wanted to see where they were going with those systems. Was there any further development? Are you looking at next gen opportunities? Are you talking video over IP solutions? Are you looking at any other standards? Those were some of the things that we were looking at as well and stuff. And so, over that 4 to 5 year period of time, we started to, realize that, hey, we needed to start focusing on some of the standards. And then we started to pilot some of the systems and stuff. And we did semester-long pilots on various systems. And we started to look at the criteria of those systems. And we looked at the complexity of installing the systems and getting them over the network. And what did we have to do? And working with our own campus engineers and network engineers, it was determined, hey, yeah, you're going to have to create your own network. So guess what? You're going to continue to repurpose your fiber to do what you need to do.
Yep.
And that was a critical decision. We needed to know that. We needed everybody to be honest with us. And so we had to understand what we had to maintain and what we could continue to do. The beautiful thing is we'd already put the infrastructure in for all our fiber to all the classrooms and stuff. So that wasn't a big issue. It was how do you repurpose it and how do you advance your systems over into the standard that we were looking at and stuff. And like I said, we looked at various standards and everything, and we finally, decided that, 2110 looked promising at the time and stuff. And so when we looked at 2110 and as you read into the standards and you start to see that, hey, it covered the transport, the synchronization, and everything as it pertains to, audio, video, and ancillary data and stuff. And it allowed us to look at how we could manage these signals now over a managed IP network and stuff. And so it made a little bit more sense to stay on a standard and stuff and to go with an open standard that was evolving and that was going to allow us to grow the system and stuff like that. And so when we got into that, once we determined that, we started looking, okay, so let's design this system. Let's look at an actual design and stuff, and I think that's, when we kind of ran into Imagine and it's like, okay, all right, we've looked at everybody else and we've looked at everybody else's systems and stuff. Now let's see yours and stuff and let's see what you have to offer. And we brought that system in, we put it in, we did a demo of it. Everything that it did was pretty impressive. We liked the connections and everything. And just from our research, we had already seen a lot of the SMPs in process and stuff. And so just going to, some of the other institutions, we visit several institutions in this whole process here. So, Sean, I, and a member of our engineering team, we traveled and stuff, and we got to go see other solutions in play, and we got to talk to our peers and say, hey, how's this been working for you and stuff, and what are the advantages of it? And you know, and a lot of our peers were using other different systems, and so it gave us some insight on the systems that were deployed as well. And so it was kind of, you know, learning lessons from others and stuff in that process. And so as we got into designing our system and making the final designs for it and everything, you know, we realized, hey, because of what we do on campus, there are short timelines to make this happen. And so we realized, okay, this is going to happen, and it's going to be less than 90 days. So from start to finish, we've got to rip out the old infrastructure and put in the new. And so we had to have confidence in everybody on the team, you know, whether it was our in-house team, our in-house engineers, our networking engineers, we had to have confidence in that and stuff, that everybody was going to pull forward. So it was a very collaborative approach, just including everybody and the input from everybody, and just seeing, you know, whether we met virtually or emails, there was a lot of communication going forward and stuff, all the way down to our AV integrator that was also involved in this process and stuff. I mean, that was kind of critical too, but it was new to everybody on this side of the world and stuff. So we were implementing a system that we needed everybody to jump in and have hands-on and be able to have a say-so and an understanding of this system and stuff. So that was kind of where we were, you know, in August, we put this system in, and in August, we were able to produce, August 2019, we were able to produce, you know, our first classes and stuff, which was a major milestone for us to go and get this system up and get everybody trained and be ready to run classes in under 90 days and stuff.
Yeah. Yeah, that's great. A 2110 system in 90 days in your space is pretty incredible. So,
yeah.
So one of the things I remember when, go ahead, Sean.
No, I was just going to say, well, it was certainly a whirlwind situation. But throughout the process, I you know, told Tony, you know, once we, you know, wrapped everything up, that it was a highly rewarding project for me personally. Just in, you know, watching the team take agency, getting input from team members, watching them and myself learn different technology related to, you know, video over IP, acquiring different skill sets that we continue to evolve to this day. So yeah, getting it done in the time frame, I think, was kind of a gift, and so we had to, you know, go full throttle and make sure we were successful.
Well, and on that note, Sean, you know, one thing I want to kind of mention when you talk about the evolution of the staff and the workflows, and we'll talk more about the operational workflows in this discussion, but one thing I want to point out now is, do you guys feel like you have to be network engineers?
No, not at all. Not at all. And,
right.
and even when we go to conferences and we talk to different people about this, you know, my full disclosure, I'm not an engineer. However, I can tell you what we learned, the skills that we acquired, the knowledge base that certainly grew over the course of the project. But yeah, it's you know, for us, it came at a time where we needed to advance our systems, and this one was relatively, and especially along with the support, the level of support that we had was tremendous. So it gave us a certain comfort level going into the fall semester that we were going to be, we would be okay.
Yeah, that's great. That's good to hear. So when you guys engaged me, one of the things I remember is we actually went through several different modeling exercises too. So one of the things I want to point out here is we do have a bird's eye of just the fiber layout, logical drawing. So one of the major benefits here, you can see this is the logical layout of the older fiber system. So I have 4 strands of single mode fiber to each classroom, essentially. So the way you guys used to use that fiber was basically you could do one single SDI signal in one direction, and that was it. So part of what we had to do, to what Tony said earlier, was figure out how to increase the capacity of the system without having to run a whole new infrastructure. And one of the benefits of 2110, regardless of whether you are connecting back to a central location or if you just want to go from point to point, is that you can actually pack more of that uncompressed video into a single strand of fiber. So this is what it looks like before we go 2110, and then we have an example of what it looks like after 2110. And so you can see that now 2 strands of those fiber for each classroom are lit up. And then you guys have 2 extra fibers that you could either go to a redundant 2022-7 style architecture for full redundancy of the system, or you could attach other devices entirely to those fibers. So, and what we're doing here is actually, instead of 1 signal over each strand of fiber, we're sending 32 HD signals completely uncompressed and with low latency, because there's no compression math involved at the beginning or the end of the transfer over those fibers. And what this enabled you guys to do with your centralized location is have the performance of a 256 by 256 router, as opposed to what you're doing before, as Tony discussed, where you kind of had to bring the signals from the classroom into one multiviewer and then bring that back to the central location. Now you guys actually have a fully dynamic router where you could take any source from one of these Selenium network processors in a closet and then pull that back. And we'll talk about some of the other interesting things that you guys can do with those processors on the edges by being on one network. But it really is like you took the inputs and outputs of a router and just pushed them out to the edges of your campus.
Right. Yeah, I think that's the power of it, Cassidy, when you speak of it. And that was one of the things we were looking at, is the capacity to grow, the expandability of the system. Right now we occupy 9 different buildings for this particular system and stuff, and just being able to look at those buildings as they are now and just growing within those buildings first allows us the opportunity to add additional resources into our system for support and monitoring and stuff. And that's the key thing for when we looked at additional capacity and stuff. And then as we look into the future, understanding now what we did before, it's pretty simple as what we need to do as we add additional buildings or spaces down the road and stuff. It makes it a little bit easier for us to swallow that pill now, because we've got an open system.
Right.
It's really not going to be a big hiccup. And as you look at it from a future capacity, when we look at what we put in the infrastructure, when we go look at the network switch we put in, we talk, in general, 32 by 32, being able to go from one classroom, but that switch at the core is something that's going to allow us to do, 1200 by 1200 in its present capacity and stuff, which is pretty cool to have capacity at your core. That's like a huge matrix for us.
And not to mention, it's a 1RU switch, right? It's a 1RU Nexus switch that has a bunch of open 100 gig ports on it. So, it's really amazing what we can do with just the sheer density of that 2110 technology, even if someone is not interested in the production aspects of 2110, like being able to move the audio and video around separately and the closed captioning separately and stuff like that. That's really cool for production. But for some of these use cases, just the density improvement is worth it. So one of the other things I want to talk about is the solution diagram that I have here that shows some of the workflow. And I want Sean to kind of talk a little more about how the system actually works. So, we tied into some of the existing infrastructure, and we wanted to make sure that on day one, you guys could have something comparable to what you've been doing before. So it wasn't like you were relearning your entire role, right? So even though we open up this big 256 by 256 router, and yes, you guys can say destination source take and move signals all over the campus, it still has to perform the way that it used to perform before any of that.
Yeah, exactly. That was critical. We talked about the time frame. So over the 3-month time frame that we started implementation or install to the start of the semester, that was a relatively tight time frame, and we didn't want the learning curve to be, as such that it caused us problems going into the fall semester, right? So ideally, we wanted it to resemble and feel similar to the old system. However, we wanted to take advantage of some of the new capabilities, and we wanted to be able to customize some of the layouts so the technicians could better manage their workflow throughout the day. And this is, this system definitely provided us with that. It gave us an opportunity to get creative, but also keep some resilience within the system in order for us to be able to make sure that we were able to still provide the same level of support from a technical standpoint, being that we were centralized.
Right. So give me an example workflow, so something's happening in the classroom. What does the teacher do? They touch this Crestron panel, and then what happens?
Well, basically, the technicians are there. Over the years, we've developed tremendous rapport with our faculty members, so they trust us, right? So we, going into the semester, we provide orientations for faculty members to get them adjusted to the classroom aspect of it. And so once we get them comfortable with the technology, some of them become more comfortable than others. Then we're there to provide support. So, a technician can be assigned, one class, two classes, maybe three at any given point throughout the day. And so the idea is for them to be able to adjust on the fly. If a faculty member runs into an issue, for the most part, the technicians are there monitoring them, on a real-time basis, so that they can hear and see and interact with faculty. They take cues, they can tell if a faculty member is about to run into some trouble, and then they can automatically respond. In situations where they may be assigned 2 or 3 courses, that may not be the case. So faculty members there are Crestron touch panels there within the classroom. They can engage a help button. The help button triggers a tally on the layouts that we produced. It indicates what room that the bat signal is coming from, and the technicians can immediately respond. So those features within the multi-viewer system definitely improves and allows us to be able to provide the level of technical support that faculty members have become accustomed to.
Yep. By having access to every single signal in that entire interconnected system, you guys can be a lot more creative and flexible with what types of multi-viewer layouts you're looking at. So where you were kind of limited to, as Tony said, sort of these quad splits and then stacking quad splits to see multiple rooms, now you guys can really be selective about what signals you're looking at a given time and provide a more dynamic kind of a support, right?
Exactly. Yeah, we have about 144 source signals spread across the 9 media enhanced classrooms that we support. And so we can access any of those signals at any given time. So we created layouts or salvos to accommodate any workflow that the technician may experience throughout the day. So we created layouts to accommodate, all the source signals from one classroom. We created templates or layouts to accommodate a double room view. We created templates that would accommodate a single classroom and maybe a Polycom's external source. And so we were able to get creative and be able to unravel and see any of those 144 source signals at any given time, and we can route those where we deem fit.
Yeah, and I remember you guys were you jumped in head first into designing layouts. I remember you had a few staff members involved with collaborating on layout design. How many sort of preset layouts do you think you guys have saved right now for the system?
Yeah, that was the beauty of this whole project, right? I talked about, the team members and their agency in this, and their contributions and collaboration, and them knowing that we understand that as an end user, that we wanted them to take agency within the project and come up with different layouts to accommodate, anything that they would need to do. So, we have, some situations where we can see all 9 classrooms at any given point. And I talked about the other layouts that we also created, but, the beauty in this is that we can also develop any other layouts that may come to fruition, especially given this time. We just don't know, how our role is going to be expanded, but we have the necessary tools to do so.
Right. Yeah, I know that many of the staff have the layout designer tool on their laptops. So you guys are actually able to build those layouts remotely and bring them in and push them to the system. So it is very flexible for you in that way. And that's definitely been a powerful thing from August 2019, but as you say, allows for all kinds of options going forward as well. So one of the things I'd also like to point out here is the future expansion capability. So it's kind of fun to look at the backplane of a Selenium network processor in your closet. we actually have, this is an example of one of these Selenium network processors in the closet attached to a classroom. So what you're looking at here is HDBNCs for SDI connectors along the back, and there's 32 of those connectors. To the left, next to the power connectors, that is actually the fiber connection that goes to that single mode system across the campus that is sending the 2110 back and forth. And one of the things you'll notice here is that not all of those HDBNCs are connected to SDI. So while NC State uses those SDI connectors locally to bring cameras into the 2110 space, or if they needed to bring something back out of the 2110 space locally, they could do it. There's also a lot of extra capacity on that 1RU Selenium network processor for ad hoc functionalities. And those things could be like from the control room, Sean and his team could say, I need to route something to that open processor to either change the audio mix or do some kind of a color adjustment to the video, or if they wanted to add up-down cross capabilities, they could even convert video formats and deal with things like UHD or 1080i to 720p or even HDR formats. The other thing by having this capacity is if they have a closet that is close enough to multiple classrooms, they could bring multiple classrooms back and use this Selenium network processor like an aggregation point. So the power that they've unlocked by going to 2110 and unlocking that density on the fiber enables them to place a far more robust device in this system than they could have placed at the edge when they were actually doing 2 signals for 2 fibers, for example. So have you guys been able to get creative yet with how you use the Selenium network processor?
Well, that's a good question, Cassie. I think you've kind of hit on all areas that we're focusing on right now, is looking at future capacity and things to do with it and stuff. And so, one of the secondary projects that we did kind of immediately after this system was implemented is we looked at the centralized recording of our classroom capture systems. And so we did go ahead and put in a centralized recording model following the implementation of the big project. We did go ahead and do that, and we have that in play now, where we actually install 4 of our classroom capture encoders into the core and stuff, and we're actually using the SMP to hit those encoders and stuff. And so now we can route from any of these other classrooms directly back to the centralized location. So we're proving the concept that we don't have to record and capture in the classrooms anymore. We can record centrally. And so we brought all that back, and now we have that capability to start that process of looking at how to expand the systems beyond just saying, let's put capture devices out on the edges there. We can just have, centralized capture devices where we can schedule them and run them accordingly more efficiently than having devices that are sitting there collecting dust and sitting dark, for maybe, 20 to 30, maybe 40 to 50% of their time and stuff. Now we can maximize utilization of our classroom capture devices as well and stuff. And that was kind of a secondary project that we put into play, and we're still growing it, we're still playing with it and stuff. And so we're looking at that, as Sean had mentioned. We don't know what the future holds, but we're kind of preparing for what we can be there for that future.
Mm-hmm. Right. So expanding on that, we've gotten to where we can perform the way we did before, right? In the legacy system, we can do that and we can exceed that. But you guys were excited about the ability to dynamically route audio and video and use this like a big router, and talking about that centralized recording, that helps you with that, to be able to route something from anywhere in the system to a central recording device. What is the plan now, kind of looking at it, as far as experimentation or training, or how you guys are looking to expand what you do with that system, just using the tools that you have now?
Well, I think, when we look at the future, we're looking at where technology is going. And so we're looking at where the application is going, but we also have to be good stewards of what we're doing on campus as well. So we have to look at, what are we doing in our classrooms? Okay, where is the classroom going at the next level? What technologies are starting to go into the classroom? So as we look at more collaborative tools that are going into the classrooms, we have to factor that into our infrastructure as well. And so we're also paying attention to everything that's going around us. The biggest thing we're looking at too, right now we're running, these media enhanced classrooms, and we have to be, kind of go back and take a look at all the tools that we've been talking about. We mentioned Polycom codecs and things like that and stuff. Well, we also have to look at that and see where are these codecs playing into that role too and stuff. There's also talk about, centralization of what we call the Polycom codec as, a high-end capture device for transmission, for collaborative applications and stuff. Well, that's not necessarily one that's maybe needed in every single classroom and stuff. And so it's a case where, yeah, you don't need one of those devices in every single classroom. If you need to bring one of those devices in, put it in the core and route to it, okay? And let's route to it as needed. That way you don't buy a device for every single classroom like that and stuff. And so there are cases, where you may need to have high-end distribution and go back to what they call the H.323 network, and hit those applications at other institutions that are still driving those codecs and stuff. And so we recognize that, and there's always going to be probably a use case for having that. But, you don't need to buy those codecs and deploy them all across the campus anymore and stuff. And so this system affords you that opportunity to say, put one in the core, route to it, route your signals to it. Now that we can route multiple signals, and typically those codecs take anywhere from 4 to 5 signals, and we can just route any of those signals there, whether it be video, content, audio, everything like that, and then we can transmit it directly. Now, the beauty of this system is it allows us to transmit things back to the destination where it was coming from.
Right.
Send the signals back now, as before, you couldn't even think about doing that because we didn't have the capacity and stuff. So it's a two-way interactive street that we're driving on now, where the signals go back and forth, which is really positive. And when we look at the future, we have to factor that into play. What applications fall into this category.
Yeah. So, and the workload of the system changes all the time, right? So having centralized resources allows you guys to say, we're using classroom 1 today, but we're not using it tomorrow. For example, we're going to use those resources for another classroom. But as an example, what is the current maximum simultaneous load as far as classes in session at a single time that might have to be supported?
Well, to give you on average, we average pretty much for what we're doing, we're doing anywhere from 70 to 75 courses a semester. Okay, so on average, you may have all 9 classrooms in operation at any particular time. There are prime time spots throughout our day to where, we're struggling with, finding additional time slots for faculty to teach in. There's certain time slots they want to teach in. And so sometimes it maximizes our system and it puts a strain on our system at that point, not because of this infrastructure. We just don't have enough classroom spaces to be able to do that. And so that's kind of the biggest thing there that we're looking at too, is this will make it really simple now to where we can tap other classrooms pretty easily and stuff. And so someone 10:15 in the morning, and there's another, media capture classroom sitting next door or something like that that's in the same building, and now that we can possibly work with our peers on campus that support those facilities to see how we can enhance that and bring it into our system, there's an opportunity there to start discussing it and stuff. And I think that's what we're looking at, is like you've already shown the capacity that we still have on some of these processors. And within those buildings, we can bring those feeds in pretty quickly, and we can be an advocate for supporting other efforts, and particularly as we talk about our distance education courses and stuff, particularly faculty that are teaching. And I think we have to clarify when we say distance education, our programs that we're supporting for distance education rely on us for a level of redundancy. So really, I can count on one hand in the past 10 years how many courses that we have lost, which is very little. Okay. In general, we have backups in place to where if an encoder goes down, the other encoder should be running. And if the case where they both have problems, then we can go back and edit between the two, just to create the material that needs to get to the students.
Right, because you still have that capture copy.
You still have that copy. And that's the beauty of the system that we run, is it's built on redundancy. So even with the system, the 2110 system, layers of redundancy we have put in place since the system was implemented. We put in, spare multi-viewer, a hot spare multi-viewer that will kick in when necessary. We just recently did the network switch that way too. So we've got everything built on redundancy. So there are no failures in the system that would prevent any of the material going to the students and stuff. And I think that's our end game, to ensure that the students get their material in a timely fashion and stuff. And like I indicated at the very beginning, once we hit stop on an encoder, it's immediately available. It's just a matter of seconds before a student can go and click on the link and voila, they're watching their course and stuff. And I think that's kind of we look at as a future, is how do we maintain that level of redundancy, that level of guarantee that a course is going to be there when a student needs it. So they need that course material. And I think that's something that the entire team, Sean and I, are part of. We pride ourselves on that. It's that customer service element to be able to offer that level of service to our students and to our faculty to be able to get that course material.
There's a confidence that it's going to be there from the students, from the faculty. There's a confidence that the product will be safe. The class is going to be there. They're going to be able to watch their class and get their credits and all of that. It needs to be there when they expect it, right?
I was just going to say that's why the support element is so critical, because the students that we service, that we support, this is their primary means of matriculating through their academic program. So it's highly critical that the support is there, the response is there. You talked about simultaneous courses, and Tony mentioned that 10:15 is a hot spot. Everybody wants to teach at 10:15 and at 1:30. So that puts additional stress on the team for them to need to monitor any of those source signals at any given time. So we're able to develop those workflows and layouts and templates to give us a level of support to ensure that end product is what the students desire.
We do have a before and after picture of the room that I want to put up here, just so people can see how we cleaned the monitors up a little. So you'll notice here that the major difference you notice right away is all the separate monitors with sort of quad splits and cascading multiviewers to try to get everything in front of the operators, right, or the staff. And then on the bottom here, we see you guys have large monitors now that are more dynamic, to talk of all the different layouts that you guys had before. So is there anything interesting to note here about the difference in the feel of the room?
One thing that we have to also mention when we're doing these courses and we run into these peak periods is that we tap our team to do more during those peak periods. So when you look at the pictures here, and I can't tell you which one, Sean probably can, but the technicians are sometimes assigned to multiple courses. So they're doing 2 courses simultaneously and stuff. And so they're having to, get one going, get that professor happy, get that course going, and then following up on another course. And a lot of times the courses are staggered and stuff. And so they're able to, to start this course and then start another course, and then the schedule's staggered that way. And that's a big emphasis on us, is we schedule things to provide a level of support for multiple courses. And these consoles allow us to do that. I mean, you could probably look in one of there, you can see maybe one of those technicians is looking at all 9 classrooms, but at any given time, he can pull up maybe the particular classes that he's assigned to and to be engaged, or he's waiting on the help button to go off, and he can sit there and, go in and help any of those classrooms at any time. And that's the beauty of the system. It's not like, one console is assigned to a particular classroom. Any of those consoles at any time can be engaged in any room and stuff. And so if one technician needs to step out for whatever reason, the other technicians can also pick up and help and monitor and do whatever needs to be done in those additional classes. So they can monitor any of the classes at any time. They can do two classes at a time, monitor 3 classes at a time, different things like that. They have the flexibility of doing that. And I think that's really the power of the workflow that's been developed, is to allow that opportunity to be a complete support vehicle across all those facilities.
Excellent. Well, thank you guys both for joining, and we're just about at the end of our time here. So any parting shots from Mr. Colvin or Mr. Pearson?
I guess I'll start off. Thank you for having us here, by the way. And as I mentioned before, this entire project was extremely rewarding for myself and for the team. And I think what we have moving forward is just going to allow us to be able to continue to scale our system and further enhance the mission of Delta in our support of distance ed programs across campus.
I'd have to concur. Thank you guys for the opportunity to talk about what we're doing. I always welcome the opportunity to show everything that we're doing with our technologies and how we're growing the system and how we're advancing all of the technologies there. And if you take a look at some of the pictures there, we didn't show a classroom, but there is a particular classroom right there that you can take a look at. That's actually, one of our model classrooms, and then our technicians and how they work at the consoles as well. So, like I said, this has been a great opportunity. Thank you for affording us the opportunity to sit and talk with you.
Yep.
And like I say, we kind of, we engage in everything. We look at technology, we look down the road, and that's one of the things we're looking at as next gen. Where are we going with this particular system, and how can we advance it to the campus and help others on the campus be successful with their course captures?
Excellent, excellent. Thank you. Well, to those listening, feel free to reach out to Tony or Sean or myself or your Imagine representative, and we'd be happy to discuss the system and 2110 further and networking solutions, and we can even provide virtual demonstrations of these technologies. So thank you for listening.